Let us continue the last class. In the last class, we were discussing regarding the analysis of pin-jointed perfect frames using method of joints. So in the method of joints, why we are using this method? This is to analyze a pin-jointed perfect frame. How can you say whether a method like a frame is pin-jointed and another one is rigid jointed? Here we are analyzing pin-jointed perfect frames. So a frame can be perfect when m is equal to 2j minus 3. If m is less than 2j minus 3, then the structure is said to be unstable and it is imperfect. When the structure is m is equal to 2j minus 3, then this is said to be perfect one, which is stable and determinate. Whereas m is less greater than 2j minus 3, it indicates that it is stable only, the structure is stable. This frame is called as redundant frame or indeterminate one. Indeterminate one. So the method of joints method is dealing with the perfect pin jointed frames where they are stable and determinate. Now we started to analyze the problem in the step one. First of all, check the stability and what is the determinacy of the structure. So when it is stable and determinate, then you can analyze the problem. So this is a given frame. There are 7 members are available. AE is one member, DE is one member, AD is one member, AB, BD, BC, CD. Total 7 members are there. And you have joints. Joint is nothing but wherever the member meets. 2 or more number of members are meeting at a point. Here A is one joint, E is one joint, D is one joint, B, C. So total joints are 5. 2j minus 3, 2 into 5 minus 3 is 7. So M is equal to 2j minus 3. The given frame is pin jointed perfect frame. It is stable and determinate. So this is step 1. The step 1, you will understand whether the given structure is stable or unstable. Whereas coming to step 2, in case of step 2, what we are calculating, we calculate the reactions of a given frame. So here there are 2 supports are available at A as well as at E. A is a pinned support where 2 reactions are available. E is a roller support where only one reaction is available. RAX, RAY, RE is there. Now the loading is already available. Considering there are how many unknowns are there? 1, 2, 3 unknowns are there. So this is 3 unknowns. You know the equations of equilibrium for a plane structure, that is sigma fx is equal to 0, sigma fy is equal to 0, sigma m is equal to 0. These 3 equations are available for the 3 number of unknowns. So you can solve with the help of your simple equations of equilibrium. So we have considered sigma fx is equal to 0. Right side will be considered positive, left side will be considered negative. So from this you got an equation, and vertically, whereas sigma fy is equal to 0, upward forces will be considered positive, downward forces will be considered negative. Considering this sign convention, we got the value of RAY. RAY. Those who are not there in the previous class, please note down the points quickly. Now, taking moment about the point, we know that clockwise will be considered positive. Just understand, once again I am saying, you might have come across with all these things in your engineering mechanics, but once again I will repeat. Sigma fx is equal to 0. It means that summation of the forces along x-axis is equal to 0. That means along in the direction of your x-axis, all the forces are to be considered. RAX, RE are the forces along x direction. Whereas sigma Fy, summation of the forces along y-axis. So summation of forces just 1 second. Now in this, so what we are discussing here, what I am saying is the forces along y direction, summation of the forces along y-axis is equal to 0. So y-axis means along y-axis, that is along y direction is equal to 0. Whereas coming to moment, summation of moment about a point here, it is not along z direction or anything like that. It is about a point. You are considering moments about a point. Here at A you are considering the moments. So about a point in z direction. So 50 into 4. So this is clockwise will be considered positive. Anti-clockwise will be considered negative. So this is, you got the values of RE as well as REX. Now, what is the next step we are doing? First of all, is to understand whether the given frame is stable structure or unstable structure. Um, the stable structure or unstable structure. So in the next step, we calculated the reactions. In the third step, we require to calculate the member forces in each member. First of all, draw the free body diagram. So to draw the free body diagram, what we have considered, what is the condition to go for the free body diagram? Can I consider the free body diagram at A or at B or at C? How should I know that I have to start considering my free body diagram from C? The condition is wherever you are taking the free body diagram, there the member unknown forces should be less than or equal to 2. Should be less than or equal to 2. That is a condition. Once again, let me repeat. Here, determine the magnitude and nature of the forces. We are going to calculate due to these external forces, What are the forces inside the member? So to calculate the forces inside the member, we are observing here the free body diagram at each individual joint. To start my problem, I am not going with the free body diagram at A. When I go with the free body diagram at A, the unknown forces are AE, AD, AB. Three unknown forces are there. And whereas coming to B, BA, BD, BC, three unknown forces are there. Coming to D, DE, DA, DB, DC, four unknown forces are available. But whereas coming to E, EA, ED, two unknown forces. At C, CB, CD, two unknown forces. Why specifically two unknown forces? Is there any like significance for this value of 2? Yes. Let me see here. If I draw the free body diagram at C, I am considering always first of all assume in your sign convention, tension will be considered positive. Compression will be considered as negative. That is the assumption we are following here in this method of joints. Tension will be considered as positive, compression will be considered as negative. In case of tension, away from how you are representing tension from the joint, if it is going away, that is considered as tension. Compression means towards the joint, if the force is acting, that is represented as compression. Now, here FBC is there and FCD is there, two forces, and they are making an angle of 36.86 degrees. How you got this angle? It is not given in the problem, but the dimensions are given. 4 meters is given, 4 meters, total is 8 meters. This is 6 meters. So tan inverse of 6 by 8, you got a value of your angle 36.86 degrees. So now here, what do we need to do here in this case? Just understand this FCD, it is not either X direction or Y direction. Resolve the forces along Y direction. Similarly, along X direction, you might have studied like a force you can resolve along X and Y axis, and this will become FCD. This is theta adjacent side. FCD cos 36.86. This one will be FCD sine 36.86. The simple way is, this is the force acting. This will be like this. So if this is F, if this is theta, this is F cos theta. This is F sin theta. Now, similar way, the resolution of the forces is done. Now, at a joint, how many equations of equilibrium are available? We discussed in the first point itself. If you go to method of joints, in the first point itself, we discussed the available equations of equilibrium at a pin joint are sigma fx is equal to 0, sigma fy is equal to 0. There are two unknowns are there, two equations of equilibrium are available, hence you can solve it. That's why, that is the significance why we are considering two. If they should be more, if it is more than two, then your available equations are not sufficient. So you need to go with the help of here. So sigma f x is equal to 0. Summation of the forces along x direction. The value is minus f BC. Why I am writing minus? Left side is considered as negative, right side is considered as positive. Minus FBC minus FCD cos 36.86 degrees. Is there any other force along x direction? Can anyone of you tell me how many forces are available along x direction? FBC is there, FCD cos 36.86 degrees is there, which is equal to 0. I don't know the value of FBC, I don't know the value of FCD, just keep it like that only. Go to the next equation, sigma F y is equal to 0. So what are the forces along y direction? This is minus 25, which is coming downward. Upward is considered positive, downward is considered as negative. Minus FCD sine 36.86 is equal to 0. So this is nothing but FCD is equal to minus 25 by sine 36.86. Minus 41.67, it doesn't have any meaning if you don't provide any units, kilonewtons. Now you should understand 41.67 is considered as magnitude that is there, and minus is nothing but the nature of the force. We are considering negative as compression, so this will be considered as compression. So the force in CD member is 41.67 and this is compression. That's it. That is the meaning. Now substitute this value minus 41.67 in the above equation. Minus FBC minus FCD is minus 41.67 into cos 36.86 is equal to 0. So what is the value of FBC? You can tell me the value of FBC, whether it is positive or negative. You should say with sign. You should say with the sign. If it is negative, say minus, or if it is positive, plus. And what is the nature of the force here? Magnitude is 33.34. Nature of the force is tension. Nature means whether it is tension or compression. So we calculated what are the forces that are available in at a joint C, that is FBC, FCD. I will go to the next joint. So which joint I have to consider? So shall I take, we started with the C. So the forces in these members are calculated. I'm just highlighting this member's force is calculated. Now we need to go with the B, A, E, D. Shall I go with the D? If I take D, how many unknown forces are there? This force is not known. This force is not known. This force is not known. Whereas coming to B, if I take free body diagram at B, BA force is not known, BD force is not known, whereas BC force is known. That's why the unknowns are two only. So we should consider the free body diagram in such a way that the number of unknowns should not be more than or equal to 2. Either 2 or less than 2, that's it. So go with the free body diagram at B, draw the free body diagram. And BD at joint E. So this is our joint. I am assuming all my forces are tension only initially. This is joint B. Towards this is FBC. This is FAB. This is force in BD. And the downward force is also acting. When you are drawing the free body diagram, along with the member forces, represent the external forces also, which is 50 Newton. So at a joint, how many unknown, like how many equations of equilibrium are available? Two equations of equilibrium are available. One is sigma fx is equal to 0. Second one is sigma fy is equal to 0. Sigma fx is equal to 0. So what does it mean? This is going in the negative direction, minus FAB, and it is going in the right side direction, plus FBC minus FAB plus FBC is equal to 0. So minus FAB plus, what is the value of BC? The previous step itself you calculated 33.34. 33.34 is equal to 0, which implies FAB is equal to plus 33.34 kilonewtons. And this is the indication of tension. So FAB value is tensile force. FAB value is tensile force. Now, going to the next one, FAB is calculated. Next, I will go with the sigma Fy. This 50 kilonewtons is acting in the downward direction, minus 50 minus FBD is equal to 0. So FBD is minus 50 kilonewtons. That's it. Just send this in the right side direction. FBD is minus 50 kilonewtons. This is compression. As it is negative, negative will be considered as compression. Positive will be considered as tension. Positive is considered as tension. Now understand here, when I go to the top of my problem, how many forces are obtained? Yes, we started getting this one. We started getting this. Now, these are analyzed. These are analyzed. How many problems? Like now, here, this is not known. This is not known. This is. We got 4 members out of 7. Another 3 members are to be determined. So which one you need to go? Either shall I go with the joint D or joint E?
Join to D, sir.
Joint D, yes. So why we are going into joint D? When you go with joint D, here total 4 members are meeting. EA, EE, EB, EC. In that already 2 member forces are already obtained. So DA and DE are ever unknowns. So when you go with that one, here you have to understand one thing. It is inclined members. At D, there are inclined members are available. So how to analyze these inclined members? So before going to that, we should know the angle. What is this angle? Can anyone of you tell me what is this angle? What is this angle? Just think of it. What is the angle made by this force DE with respect to horizontal? See this. This is theta. We already obtained the value of theta, which is 36.86. It is the same line. So this is also 36. And this is theta. This is also theta only, 36. And this distance is 3 meters. This height is 3. This is 4. 3 by 4. Tan inverse of 6 by 8 or tan inverse of 6 by 3 by 4. Both are the same. This is also the. Draw the free body diagram at D. So next one. Free body diagram at D. D, how many forces are there? This is your D point. Vertically upward one force is there, which is force in BD. Another force is going like this, which is force in CD. Another force is going like this is force in BE. Another force is going like this force is AD. So this is your x-axis. At x-axis, this angle is 36.86 degrees. 36.86 degrees. This is also 36.86 degrees. As the forces are inclined, they are to be resolved along x-axis. So this FCD I am resolving. How I am resolving this FCD? So this will be FCD cos 36.86. Whereas this force in the vertical direction FCD sine 36.86. Just the thing is, if this, you are making an angle theta with respect to horizontal, horizontal is FCD cos theta, vertical is FCD sine. That's it. Now coming to here, here also, this angle is here, FAD cos 36.86. It is resolving of the forces along x and y direction. That's it. I am not doing anything new. You might have studied in your diploma or intermediate or in the first year BTech. Only I am resolving the forces along x and y directions when there is acting with an inclined plane. So this is FAD sine 36.86. As coming to FDE, FDE force, this is in this direction. FDE sine 36.86 is, this is FDE cos 36.86. That's it. Now sigma Fx equal to 0. Summation of the forces along x-axis minus FAD cos 36.86 minus FDE cos 36.86 plus FCD cos 36.86. Is there any other force along x direction? 1, 2, 3. Right side is considered positive, left side is considered negative. And we make it to 0. This cos can be cancelled, and this is nothing but FAD minus FDE plus FCD is equal to 0. Minus FAD minus FDE minus 41.67 is equal to 0. So when you take simplify this, this will be obtained as FAD plus FDE is equal to minus 41.67. I hope you are good in sign convention. Don't get worried about this left side and right side, and you get an equation like this. FAD plus FDE is equal to minus 41.67. Whereas coming to sigma Fy is equal to 0. Summation of the forces along y-axis. What are the forces that are available along y-axis? This one is available. Minus FDE sine 36.6 is negative as it is coming downward direction. Then this is the plus FAD plus FAD sine 36.86 plus FCD sine 36.86. Yes or no? FCD is also going in the upward direction, so plus FCD sine 36.86. Is there any other force or is equal to 0? Shall I make it is equal to 0? We have written FDE vertically downward direction, FAD vertically up, FCD vertically up. What about FBD? FBD is also acting in the upward direction, so FBD is equal to 0. So substitute the values which are known to us. FCD is known, FBD is known. So sine 36.86, what is the value of sine 36.86? What is the value of sine 36.86?
0.599, sir.
0.6 I can write down.
Okay.
So minus 0.6 into FDE. Yeah, 0.599 something. So 0.6 FDE plus sine 36 point, that is also 0.6 plus 0.6 into FAD plus what is the value of FCD? minus 41.67, sine 36.86 is 0.6 plus FBD. Can anyone of you tell me what is the value of FBD? Now simplify this and tell me the equation. Minus 0.6 into FDE plus 0.6 into FAD is equal to how much? This left side it has to come in the right side direction. Yes, further you can simplify this FAD minus FDE. Just this 0.6 can also be sent in the right side direction as by 0.6. Tell me the final value. Assume this as your equation number 1. This is equation number 2. You know how to solve equation 1 and 2 to get the values of FAD and FDE? Simply they write down the equation number 2 here. This is equation number 1 is equal to minus 41.67. So this is even equation number 1. Just a summation of these two equations. 2FAD is equal to, what is the value? 125 minus 41.67. Positive only. So FAD is 41.67 kilonewtons. Substitute this FAD value in the above equation to get the value of your FDE. Use any one of the equation. So FDE is nothing but minus 41.67 minus 41.67, which is minus 83.34 or 33. You can write down as 83.33 kilonewtons, which is for the forces in FAD, FDE. Just go to the problem. FAD is this one. This is calculated. FDE is calculated. Now we require only one member, that is AE force is to be calculated. You can go to either free body diagram at A or free body diagram at E. I will go with the free body diagram at E. So note down. Free body diagram at E. So free body diagram at E is nothing but policy, yes. So here the free body diagram at E is calculated. So the free body diagram at E is nothing but reaction force RE is there. Understand here. When I am drawing the free body diagram, we are assuming that all the forces inside the members are tension initially. We are assuming like that. This force, that's why I am representing it as away from the body, force in AE. And this is force in EE. And what is the angle made by this one? This is theta. It's 36.86 degrees. I am always representing my member with horizontal angle only. You can also represent like this, but I am representing with the horizontal angle only. And my assumption is the force in the member is tension. Remember, that's why away from the body. If it is not tension, and if I get negative, that indicates that the force is in compression. That's it. So what do you require? You require force in AE. AE force is required. Okay. So to do that one, shall I take sigma fx is equal to 0 or sigma fy is equal to 0? Which one is to be considered? Vertical direction. So sigma fy is required. Here my unknown forces are only one. So no need to go with sigma fx. So here the force is FDE. Now resolve the forces along x direction as well as y direction. This is force in DE, which is sine 36.86 degrees. This is force FDE cos 36.86 degrees. Now take sigma Fy is equal to 0. Remember here wherever that is required, there only you have to consider plus FAE plus FDE sine 36.86 is equal to 0. Summation of the forces along y direction is equal to 0. Sakash. So this is my plus into. Don't simply write the magnitude. You need to mention the sign convention also into sine 36.86 is equal to 0. Now tell me what is the value of FAE, whether it is positive or negative, say the value. What the expectation from the problem is calculating the magnitude as well as the forces, magnitude of the force as well as nature of the force we need to calculate. So ultimately what we will do is we will prepare a tabular form for the answers. So along with me, please note down serial number, length of the member, length of the member in meters, length of the member in meters, then magnitude of the force, magnitude of force in kilonewtons, and finally nature of the force, whether it is tension or compression. That's we are going to calculate. So serial number 1, how many members are there? We have total 7 members are with us. So the thing is, let me extend the table. At the end, after completing all, after attaining all the forces in the members, you need to represent them in a tabular form. Sir, my class phone, sir. So the member is AB. Second member is BC. Third member is CD. Fourth one is DE. Fifth member is for A, there is a link with AD. Sixth one is A is connected with E, AE. Seventh one is B is connected with B. Just once again, you can check with your diagram, which is there in the previous page of your book. Just turn the page and once again check it. Now we need to represent them with the lengths of the members. What is the length of the member? AB is 4 meters given. BC is 4 meters. Just go to the tabular form, go to the diagram of the, it is given as 4 meters. This is 4 meters. BD is 3 meters. If BD is 3 meters, this is 3, this is 4. This is square root of 3 square plus 4 square. What is the value? 5. This is also 5. This is also 5. This is 6. AE is 6 meters. So simply I am just calculating the lengths of the members. CD is 5 meters, ED is 3 meters, AE is 6 meters, 5, 5. The lengths of the members are calculated. Now you people will help me. What is the magnitude of the force in AB? We have written the magnitude of the forces as well as nature of the forces. Okay, fine. So with this, I'm stopping my class.